So again, good morning guys. Last class we were discussing on dynamics and we have solved two problems on simple problems on dynamics, right? So what is the difference between statics and dynamics? The only difference that you are doing while in your problems is that in statics you will consider the total force or net force will be considered as 0, whereas here this will be considered as mass into acceleration. Total net force is ma. Okay, that too, the net force is calculated, the positive sign is calculated for that force which is for that force where the object is moving. That direction is considered as positive. Okay, once again we will do that. See, it's a very important and interesting problem. Two blocks A and B are held stationary 10 meter apart on a 20-degree inclined plane as shown in the figure. The coefficient of friction between plane and block A is 0.3, while it is 0.2 between plane and block B. If blocks are released simultaneously, calculate time taken and distance traveled by each block before they are at verge of collision. Okay, so it's an interesting problem. There are two blocks A and B. Their respective weights are given and they are separated by a distance, say 10 meter. Okay, and this is placed in an inclined plane whose angle is 20 degree. Okay, the coefficient of friction between plane and block A, this is the plane and this is block A, it is 0.3, while it is 0.2 between plane and block B. Okay, here the coefficient of friction is 0.2. This is actually mu A and this is mu B. This has been given in the question. See, if both the blocks started its motion, that means if both blocks are released simultaneously at the same time, both blocks are released. Okay, calculate the time taken and distance traveled by each block after they are at verge of collision. So from here what happens? A started moving this side, B also moving this side. So while moving around this plane, at some point, say about this point, these both blocks are collided. Okay, this is A and this is B. Okay, so up to that point or at the verge of collision, they are just collided, that's all. Up to that point, what will be the distance traveled? That means A will be traveling from here to this distance and B will be traveling from here to this distance, right? If we assume that this is the distance. Okay, so that distance we need to find out. And similarly, what is the time taken by these two blocks before collision? That means you will release A and B from here, they both will go and meet at a point. So the time taken by these two blocks will be same, right? At what time both collides? So they will be having a common time. From A, say 1 second, 2 second, 3 second, B is coming, same 1 second, 2 second, 3 second, 4 second, 5 second, it meets here and it collides. Okay, so time is same, but distance is not same. Okay, so this is what the question is telling about. Okay, so there's a small logic that has to be used. You know that the object is going to collide somewhere. What does that mean? A is moving like this and B is moving like this. So A is not going to collide on B because it's not going like this, right? So B is coming and colliding with A at some, say, this point, right? That means the acceleration of A should be less than or greater than? Less than that of B. Okay, so A should be say 2 meter per second, means this may be some 5 meter per second. Then only it can reach together with A and collide, right? So this is the basic logic that you have to use. So it has been given, angle has been given, alpha is equal to 20 degree, coefficient of friction of A and B is given, weight has also been given, and distance between two blocks, say I'm taking it as S, okay, or distance is 10 meter, okay. We need to find distance traveled by A, that is SA, distance traveled by B, SB, and the time taken, okay. See, I have, before finding distance traveled by block, we need to find acceleration of each block, okay. Say AA and AB, I am taking it as acceleration. The logic used is, in order to have collision of A and B, AB should be greater than AA. Okay, now you draw the free body diagrams of A and B. A and B. See, A 250 Newton is inclined. The same thing that we have done here. The free body diagram will looks like, see, this will be R, reaction, no force here, but friction will be there towards this side, weight is along this side. That means this is the axis, reaction will be here, weight will be in 1 to 3rd quadrant, right? So here 1 to 3rd quadrant, and that will be, angle will be 20 degree. Okay, if you resolve it, this will be 250 cos 20, 250 sin 20, and this is 0.3 RNA. So reaction for, don't give it as RN both for A and B. Reactions will be different. Okay, RNA and RNB here. Okay, similarly here also. Right? Now the net force in X direction. See, X direction means here this is the X direction and this is the Y direction. This is the X direction and this is the Y direction. Okay. So net force in X direction, how you should write for dynamics problem, where the body is moving, that side should be taken as positive, right? So this is moving along this side. So 250 sin 20 minus 0.3 RNA or RA. Okay. Similarly, net force here is 500 sin 20 minus 0.2 RNB, because B also it's moving along this side. Right? Now, in Y direction, is there any movement? No. Okay. So, equilibrium in, this is Y direction, sorry. Equilibrium in Y direction, that means this, we assume it as Y. Okay. There is no movement in that. The object is moving only along this side. So, equilibrium in Y direction means, see, RNA equal to 250 cos 20 and RNB equal to 500 cos 20. Okay, so you got the values of RNA and RNB. Now in Y direction, net force is equal to mass of A and acceleration of A. Here also mass of B into acceleration of B. Net force we found out 250 sin 20 minus 0.3 RA. RA we found out from here, and here RB also found out. Okay, substituting in this equation, 250 sin 20 minus 0.3 RNA equal to 250 by 10. This is mass, so you have weight given by 9.8 or 10. I am assuming it as 10 into AA to AB. From these two equations, you found out acceleration of A and acceleration of B. Now, why you found out acceleration? We need to find out distance and time. So, for laws of motion, we need to know either acceleration or velocity. Okay, then only we can find distance as well as time. So from, I hope you know all these equations. From laws of motion, v square is equal to u square plus 2as, s is equal to ut plus half at square, v is equal to u plus at. So here we don't have velocity. So velocity terms, that equation cannot be used. So you need to use this equation. S is equal to ut plus half at square. That means here u is for A as well as B. initial velocity is 0. Okay, so S is depends. Okay, that is what we need to find for A as well as B. Okay, and acceleration we found out for A and B. T is common, T. Okay, now again we'll come back to this diagram from A and B. If we assume A and B collides at a distance from A, it is x. At this point they collides at a distance of x. Then you are sure that A will travel x means B should travel 10 plus x, because the distance between A and B is 10. Okay, so for block A, SA is equal to UAT plus half AAT square, and block B, SB equal to UBT plus half ABT square. Both will be having same t, time t up to collision. Okay, so from this diagram, SA is x and SB is 10 plus x. Initial velocities are 0. So for block A, x is equal to 0, UT. UAT is, UA is 0. So 0 plus half into AA is 0.601. Right? Substitute it. X is equal to 1 by 2 into 0.6 t square. And here also 10 plus x is equal to something like this. Okay. And then you'll get, substituting this third equation in first equation, you'll get, we can solve it like this, and you will get the answer t is equal to 4.61 second, and also substituting the equation you will get x is equal to 6.386 meter. Okay, so this is a very important and interesting problem. Students, please copy it down, and if you have any doubt, please message me. Okay, thank you.